Hello children, how are you all? Welcome to another session of digital classes. Children, in the last class we have studied about atom and molecules. We have studied the definitions about elements and compounds. Children, three different conical flasks in which chemical reactions are taking place. Children, there is some chemical reaction taking place. How do these chemical reactions take place? Let us study in this lesson. So, we have studied about elements, molecules, atoms and compounds. How are these formed? Children, the name of the lesson is atoms, molecules and chemical reactions. So, before going to the topic, let us define what is atomic mass. Atomic mass of an element is defined as the average mass of all the isotopes of the element as compared to 1/12 of the mass of one carbon 12 atom. According to latest IUPAC recommendations, the AMU has been replaced by U, which is known as unified mass. Atomic weight versus atomic mass. Atomic mass is the sum of protons and neutrons of a single atom. Now, we know that the atomic number of carbon is 6 and the atomic mass of carbon is 12. That means there are 6 protons and 6 neutrons in this atom. So, total atomic mass of carbon atom is 12. Now, what is atomic weight then children? It is the average of the atomic mass of all the natural isotopes of an element. Here carbon 12 if you are taking, it has 2 isotopes, carbon 13 and carbon 14. So, if you take the average will be 12.0107. So, this is the atomic weight of carbon atom. Children, so if you are taking one whole carbon atom and dividing it into 12 pieces, then one piece, that is 1/12 of this carbon atom is considered as one unit, one atomic mass unit. So, mass of one atom, if it is 12 AMU, that means 12 AMU of carbon atom is equal to 12 parts of the carbon 12 atom. So, what is 1 AMU children? It is mass of one carbon atom by 12 parts, and that is equal to 1.66 into 10 to the power minus 24 grams. So, one atomic mass unit is equal to 1.660539 into 10 to the power minus 24 grams. Now, what is molecular mass? We know that a molecule is formed by the combination of different atoms. So, the atomic mass of different atoms combined together or added together, we get a molecular mass. So, let us define what is molecular mass children. The molecular mass of a substance is the sum of atomic masses of all the atoms present in a molecule of the substance. As atomic mass is relative, it is therefore the molecular mass is also relative. So, mass of a molecule is expressed in unified mass U. So, molecular mass and formula unit mass of methane, let us calculate. In methane we have one carbon atom and we have 4 hydrogen atoms. What is the atomic mass of carbon atom? 12 AMU. And what is the mass of one hydrogen atom? 1 AMU. So, the molecular weight of CH4 is calculated as 1 into the atomic mass of carbon atom is 12 plus the atomic mass of hydrogen atom is 1.01 into how many are there? 4 are there. So, totally we are getting the molecular weight of methane as 16.05. Now, let us calculate the molecular mass of sulfuric acid. The formula of sulfuric acid is H2SO4. That means there are 2 hydrogen atoms, 1 sulfur atom and 4 oxygen atom. So, how are you going to calculate the molecular mass of H2SO4? So, we have 2 atoms of hydrogen atom. So, 2 into atomic mass of hydrogen plus 1 sulfur atom is present. So, 1 into atomic mass of sulfur plus 4 oxygen atoms are present. So, 4 into atomic mass of oxygen. Altogether, we will be writing it as the atomic mass of hydrogen is 1, atomic mass of sulfur is 16, atomic mass of sulfur is 32 and atomic mass of oxygen is 16. So, we get 2 into 1 plus 32 plus 4 into 16 is equal to 98 U, 98 units. Now, calculate the molecular mass of water molecule. Formula of water molecule is H2O, 2 hydrogen atoms and 1 oxygen atom. So, how are we going to calculate the molecular mass? 2 into atomic mass of hydrogen plus 1 into atomic mass of oxygen, and that can be written as 2 into 1 plus 1 into 16, and that gives rise to 18 U. Children, molecular mass of hydrogen is 2 into 1 mu of hydrogen atom atomic mass plus 16 mu, that is atomic mass of oxygen atom, and if you add together we will be getting as 18 mu. So, here this is the weight of one water molecule. So, as you can see, this is the structure of a water molecule. It has one oxygen atom and two hydrogen atoms. Let us go to the next topic, that is mole concept. So, what is mole? A mole means heap. Children, heap means similar particles arranged together is called as a heap. So, it can be a mole of molecules or it can be a mole of atoms. So, a mole substance can be considered as a heap of atoms or molecules. 1 mole of substance is the amount of substance which contains as many particles. It can be atoms, molecules, ions, etc., and which are equal to the atoms present in exactly 12 grams of carbon 12 isotope. Now, if you are considering 12 grams of carbon 12 isotope, why only 12 grams, children? Because it is the atomic mass of carbon atom. So, if you are considering 12 grams of carbon 12 isotope, the total number of particles present in it is called as the Avogadro number, and that number was given by Avogadro. So, if you are considering a mole of ions or mole of atoms or a mole of molecules, the mole of particles should be equal to the Avogadro number given by Avogadro, and that should be equal to the number of particles present in 12 grams of carbon 12 atom. Then what is the number of that particle, children? So, concept of mole was given by Avogadro. He is Mr. Avogadro. So, for example, if the molecular mass of water is 18 mu, then the molecular mass of water is said to be as 18 grams. So, 18 mu water has only one molecule of water, but 18 grams of water has 1 mole of water molecules, that is equal to 6.022 into 10 to the power 23 molecules. So, children, if you are considering only one water molecule, that means one oxygen combined with two hydrogen atoms, then the mass of this is equal to 18 mu, 18 atomic mass unit. That means it is 18 times more than 1/12th part of carbon 12 atom. 1/12th part means, you remember, we have taken a carbon 12 atom and divided it into 12 parts, and that one single part is equal to 1 AMU, 1 mu, or 1 U we have written it as. So, that is equal to 1 atomic mass unit. So, here one water molecule if you are considering, that means one oxygen atom combined with two hydrogen atom, the weight of one water molecule is equal to 18 mu, 18 atomic mass unit. But like that, if you are taking 6.023 into 10 to the power of 23 water molecules, and that will be equal to those many particles together of water molecules is equal to 18 grams, that is equal to molecular weight of water. A mole of water contains Avogadro number of molecules. So, this is a single molecule, children. Single molecule means one oxygen atom combined with two hydrogen atom, and that is equal to 18 atomic mass unit or 18 mu. And if you are collecting Avogadro number of molecules, and that if you are taking it in as a heap in a glass, then the weight of this is equal to 18 grams. Then we call it as 1 mole of water molecules. So, the number of particles present in 1 mole of any substance has a fixed value of 6.022 into 10 to the power 23 molecules. It can be atoms or it can be molecules or it can be ions. So, we just have to say Avogadro number of particles are present in 1 mole. Now, this number is called as Avogadro constant, represented as Na. So, children, Avogadro number is 6.022 into 10 to the power 23. You have to remember this number, children. So, 1 mole of water molecule is equal to 18 grams of water. What did you understand by this, children? That means, as I told you, carbon 12 atoms contains Avogadro number of carbon 12 atoms. Like that, if you are considering 1 mole of water molecules, what is the molecular mass of that water molecule, children? It is equal to 18 grams. So, 1 mole of water molecule is equal to 18 grams, that is the molecular mass of water. That means 18 grams of water contains 1 mole of molecules. So, what is molecular mass, children? 1 mole of any molecules combined together, we call it as the molecular mass of that particular substance. It can be water, it can be solid, it can be liquid, or it can be any type of chemical. So, the mass of 1 mole of substance which is expressed in grams is called as its molecular mass or molar mass. The molar mass or the molecular mass are numerically equal, but the molar mass has units in grams and molecular mass has unified mass units. So, number of moles can be calculated by a formula, mass of a substance by molar mass. So, molar mass is the molar mass of water molecule is 18 grams, that means it is the mass of 1 mole of water molecule. So, number of moles in 36 grams of water molecules can be calculated as 36 by 18, that comes to 2. So, there are 2 moles of water molecules in 36 grams of water. Now, you can also calculate the number of moles if the particles are given. For example, if I am telling you 12 into 10 to the power of 23 number of particles are present, that means how many moles are present? As we know that the number of particles present in 1 mole is equal to Avogadro number. Then if I am giving you 12 into 23 particles, how many times of it are present in it? 2 times, because 6.023 into 10 to the power of 23 into 2 is 12. So, it can be calculated by using a formula, number of moles is equal to the total number of particles present divided by Avogadro number. So, total number of particles we had was 12 into 10 to the power of 23 by the Avogadro number is 6.023 into 10 to the power of 23, and that comes to moles. So, children, we can summarize it as mole means it has Avogadro number of particles. So, if I am taking 1 gram of hydrogen atoms, it contains 6.022 into 10 to the power of 23 atoms of hydrogen. If you are taking a molecule of oxygen, that means O2. O2 means it contains only 2 atoms of oxygen. So, the molecular mass of oxygen is 32 AMU. Now, if I am taking 32 grams of oxygen molecules means it contains how many particles? Avogadro number of particles, Avogadro number of oxygen molecules in it. So, O2 gas if you are taking, and if it has Avogadro number of oxygen molecules in it, then we consider it as 1 mole of oxygen gas. Now, children, 1 mole of oxygen gas means how many particles are present? 6.022 into 10 to the power of 23 particles of oxygen. Particles means here we are considering it as molecules. Now, if you are taking 2 grams of hydrogen molecules, 2 grams of hydrogen molecules means what, children? H2 gas. Here we have taken hydrogen atoms only. So, we said here 6.022 into 10 to the power of 23 atoms. But now, if I am taking a hydrogen gas which contains a diatomic hydrogen molecule H2, then what is the molecular mass of H2, children? It is 2 mu. And if you are considering Avogadro number of molecules of hydrogen, then the molar mass will be 2 grams, and that is called as 1 mole. But the same way, if you are considering 16 grams of oxygen atoms also, 16 grams of oxygen atom contains Avogadro number of atoms of oxygen. So, children, mole means Avogadro number of particles should be present. If you are considering molar mass, that means Avogadro number of molecules are present in that particular gas. So, you can also summarize it as 1 mole means 1 gram atom of atoms, 1 gram mole of atoms, or 1 gram formula mass of that particular substance. 1 mole contains Avogadro number of particles, and if you are considering a particular gas, 1 mole of any gas like H2, O2, N2, it occupies 22.4 liters of gas. Now, this gas is called as molar volume. That means 1 molar mass of any gas contains Avogadro number of molecules in it, and it occupies 22.4 liters of gas at NTP, normal temperature and pressure. So, you can also calculate number of moles by using a formula, amount of substance in grams by molar mass. Number of molecules also you can calculate. That means, if you are having 2 moles, So, each mole contains Avogadro number of molecules. So, number of moles into Avogadro number of molecules will give you the number of molecules. Children, 1 mole of any gas like helium, nitrogen or methane, it occupies 22.4 liters of volume at STP. So, 1 mole of helium contains Avogadro number of helium molecules. Children, as helium is a monoatomic molecule, that means it contains only one atom. So, you can just say that 22.4 liters of helium gas contains Avogadro number of helium atoms. Now, if you are considering 1 mole of nitrogen molecules, 1 mole of nitrogen molecule contains 6.022 into 10 to the power of 23 molecules, and 1 mole of methane gas, it occupies 22.4 liters of volume and it contains Avogadro number of methane molecules. Children, this is written in at STP conditions only. STP means standard temperature and pressure. Standard pressure is 1 atmospheric pressure, children. Standard temperature is 0 degrees centigrade, children, that is 273 Kelvin. Then the number of molecules at STP is equal to 6.02 into 10 to the power of 23. Now consider the mass. Here the mass of helium gas is equal to 4 grams, and then the mass of nitrogen gas, 1 mole of nitrogen gas is equal to 28 grams and 1 mole of methane gas is equal to 16 grams. This is the molar mass of these particular gases. It is equal to 1 mole of helium gas is equal to 4 grams, 1 mole of nitrogen gas is equal to 28 grams, 1 mole of methane gas is equal to 16 grams. I hope you have understood, children. Now coming to the next topic, chemical reactions. So chemical reactions means what, children? In a chemical reaction, when two new substances combine with each other at a particular temperature and pressure, then we form a new product. So by this, what did you understand? When reactants, the new substances, when they are combining together, we get a completely new substance which are called as products. It is written in the form of an equation, children. In this equation, we write the substances which are reacting with each other called as reactants on the left hand side of a equation, and the new products which are formed are written on the right hand side of the equation. In between we write an arrow. That means these substances combine together to form new products. Now chemical combination. Chemical combination is one particular type of chemical reaction, children. In this, if you see one example, magnesium ribbon, if you are taking and heating it in the presence of oxygen, then we get a new product, that is magnesium oxide. Children, in this reaction we can see that magnesium and oxygen are reactants. When they are combining with each other, we are getting a new product which is a dazzling white color powder, and that is called as magnesium oxide. So magnesium and oxygen are reactants which combine with each other to form magnesium oxide. You can write it in the form of a chemical equation, that by taking reactants on the left hand side and writing the new products on the right hand side, separating them with a arrow. So in this equation, what did we write, children? Magnesium and oxygen are combining with each other to form magnesium oxide. The formula of magnesium oxide is MgO. So like this, you are taking a magnesium ribbon. When you are heating it, burning it in the presence of air, you see dazzling white color smoke and a white color powder formed. Here this is magnesium oxide. So, like this you are taking a magnesium, when you are heating it, burning it in the presence of air, you see dazzling white color smoke and a white color powder formed here. This is magnesium oxide. So, a chemical combination reaction can be defined as a reaction in which single product is formed from two or more reactants, and this type of chemical reaction is called as chemical combination reaction. Now, let us see, it is in the form of a picture. A plus B are the two new reactants. When they are combining with each other, we get a new product A, B, one single product. So, two substances are combining. So, this reaction is called as a chemical combination reaction. One more example, children. Hydrogen, when it is burnt in oxygen, we get water. We can also call it as hydrogen monoxide. So, hydrogen and oxygen are reactants. They completely react with each other to form water. Now, the next type of chemical reaction is decomposition reaction. Now, let us do one experiment, children. Calcium carbonate is a limestone which is solid. When you heat the calcium carbonate taken in the boiling tube over a flame of spirit lamp or a Bunsen burner, then you will be seeing a white color gas which is coming out, and if you are bringing a burning matchstick near the gas, the matchstick will be put off like this. So, this is a boiling tube, children. You have taken calcium carbonate in the boiling tube and you are heating it on over a Bunsen burner. Then you can see a white color gas evolving out through the delivery tube, and if you are bringing a burning matchstick near the delivery tube, then you will see suddenly the flame will put off. That means this is a fire extinguisher gas. Now, tell me, what is the gas which is used in the fire extinguishers? Carbon dioxide. So, what is the gas evolved from this boiling tube, children? Carbon dioxide. Now, let us represent it in the form of an equation, children. Calcium carbonate is also called as quick-limestone. Now, this, when it is obtained in a solid state, we are writing it as S. So, this is a reactant which is written on the left hand side. Now, on heating, this is an arrow, this says gives rise to, we are getting two products. So, one single reactant gives rise to two products. What are the products? Calcium oxide and carbon dioxide. Now, calcium oxide is obtained as solid state which stays back in the boiling tube, and carbon dioxide is obtained in the gaseous form which escapes out from the boiling tube. So, carbon dioxide is obtained in the gaseous state. So, we have written it as G in the brackets. Let us see one more example, decomposition of lead nitrate. Lead nitrate is a solid salt. It is heated and we get again two more products. So, one substance when it is heated, then we get two new products. This type of reaction is called as decomposition reaction. So, take 0.5 grams of lead nitrate powder in a boiling test tube. Now, if you are heating it, then you can see a reddish brown gas coming out, and that reddish brown gas is nitrogen dioxide. So, a lead nitrate mixture when you are taking and heating it over a Bunsen burner, and then you can see a reddish brown color gas fumes coming out, which is nitrogen dioxide. So, what did you understand, children? Here when you are heating this lead nitrate, you can see this reddish brown color gas is nitrogen dioxide. So, one single reactant, that is lead nitrate, on heating we have got three new products: lead oxide in the solid state, nitrogen dioxide in the gaseous state, and oxygen in the gaseous state. So, one single product has decomposed into three new products. So, children, this is the molecular formula. Lead nitrate on heating, we are getting lead oxide, nitrogen dioxide and oxygen. So, children, you have to represent the equation properly. Now, let us see one more example, children, electrolysis of water. Now, you can do this experiment at home also, children. Electrolysis, the word itself is telling that water molecule is broken. Lysis means broken by using electric energy. So, electrolysis means decomposition of water molecule using electricity. Now, you can take a plastic mug and make two holes on its base. Now, you can take a rubber stopper and insert it into the holes. You can also use pencil at a school, or you can use graphite rods as electrodes. Now, you can connect these graphite rods or electrodes to 9 volts battery, and you can switch on the current, and after some time you can see bubbles coming out. So, you can make the setup like this: take a plastic mug, make two holes under the base of this, and then introduce two graphite rods. On this graphite rod, you can just invert two test tubes, and connect these electrodes to 6 volts battery or 9 volts battery. Now, in this water add a pinch of salt or hydrochloric acid. Then after some time when you pass current, you can see bubbles coming out from these electrodes and getting collected in the test tubes which are inverted on the electrodes. Now, what are these bubbles, children? In one of the test tube you can see more gas getting collected, and in other test tube you can see less gas getting collected. Now, more gas which is collected is hydrogen, which is connected to the negative terminal, and less gas which is collected is oxygen, which is connected to a positive terminal. So, like this we understood that the water molecule formula is H2O. So, when H2O is decomposed by using electricity on electrolysis, we get hydrogen and oxygen gas separately. In this experiment we have seen that water molecule on decomposition by electricity, that is electrical decomposition, which is in the water molecule which is in the liquid state has decomposed into hydrogen gas and oxygen gas. A chemical equation can be written as 2H2O gives rise to 2H2 plus O2. So, now coming to the next type of chemical reaction, children, displacement. Displacement, that means the place of one atom is taken by the another atom. The place of weaker atom is being displaced by a stronger atom, a more reactive atom. For example, if you are taking zinc granules in a test tube and then adding some amount of hydrochloric acid into it, dilute hydrochloric acid into it, then after some time you can see white color gas coming out, and there is a salt formed at the tip of the test tube. Now, what happened in this reaction, children? Zinc reacts with hydrochloric acid to form zinc chloride salt, and a hydrogen gas is evolved out. How do you know that that is a hydrogen gas, children? If you bring a burning matchstick or a burning splinter near the tip of the mouth of the test tube, then you can see that the flame will be put off. So, hydrogen gas will not allow the flame to burn. So, it will be put off with a pop sound. So, what is the chemical reaction taking place here, children? Zinc granules react with hydrochloric acid to form zinc chloride solid and hydrogen gas. So, displacement reaction, one element displaces another element. So, mainly in displacement of hydrogen from acids by metal take place. Children, see this equation, children. BC is a molecule, A is a more reactive element, B is being replaced by A. So, what are the products formed, children? B has been replaced by A. So, new product which is formed is AC and B has come out. So, the reaction can be written as A plus BC gives rise to AC plus B. So, just now we have seen the reaction, children. It can be written in the form of a chemical equation like this: Zn plus 2HCl gives rise to ZnCl2 plus H2. Children, zinc granules we have taken in the solid state, and that is why we have written S. HCl dilute solution we have taken, so we have to write it as AQ, aqueous form. ZnCl2 is formed in the solution, so we are writing it as AQ. Hydrogen is a gas which is liberated, so we are writing it as G. Double displacement reaction, children. Here mutual exchange of ions take place. That means, for example, here AB is one molecule, CD is another molecule, children. Now, A and D they combine to form a new product, and B and C they combine to form a new product. Here mutual exchange of ions have taken place. So, this has also displaced and this has also been displaced. So, here we see that the reactants are AB and CD. The new products which are formed are CB and AD. So, children, one example here is lead nitrate solution. When it combines with potassium iodide, we see new products formed, that is lead iodide and potassium nitrate. So, lead nitrate gets decomposed, potassium iodide gets decomposed, and their ions get mutually exchanged, forming lead iodide and potassium nitrate. So, like this a precipitate can be formed. This is a lead nitrate solution and this is a potassium iodide solution. When they are combined with each other, a yellow color precipitate lead iodide is formed, a clear solution of lead nitrate can be seen. Children, let us see what is oxidation and reduction. Oxidation means oxidation, addition of oxygen. In this oxidation reaction, we also see removal of hydrogen atoms and loss of electrons. Now, what is reduction? Reduction means addition of hydrogen atoms, removal of oxygen atoms and gain of electrons. So, children, we can summarize it as Oxidation is a chemical reaction that involves the addition of oxygen or removal of hydrogen. Reduction is a chemical reaction that involves the addition of hydrogen atom or removal of oxygen atoms. So, like this, here loss of electrons means oxidation and gain of electrons means reduction. Leo says gar. Leo means what, children? Lion. L-E-O. Loss of electrons is oxidation. It says gar. G-E-R. Gain of electrons is reduction. So, what we have learned, children? We have studied about different types of reactions. We have studied about molar mass. We have studied about combination reactions, decomposition reactions, endothermic reactions, displacement reactions and double displacement reaction. We have also studied about oxidation and reduction. Please answer these questions, children. What is combination reaction? What is decomposition reaction? What is displacement reaction? What is oxidation? What is reduction? And what is corrosion of metals? Please download the worksheets from SCERT website for better learning and good practice. I hope you have understood the lesson, children. Let us meet in another interesting session of digital classes. Thank you.